Hello everybody. This video will be a recap of this week's AALD workshop on processing. In this video we'll cover conditionals in the first part and arrays in the second part, as well as the .network example, which is here. So let's put that away. So conditionals, let's think of it, you can think of it this way. Say we had a variable a is equal to, let's say, 1. Okay. So an if statement has, it starts off with if, then in brackets here, you put in the condition, and then you close, like you set the open bracket, close bracket to denote the code block which will get run when this condition is true. So the first condition we'll set is going to be, let's say if a is equal to 1, yeah. So if a is equal to 1, we're going to say print line, and we're going to say a truth. Let's say the earth is round. Okay, so that's what will get run when this condition is met. And right now a is equal to 1, so if we were to run this, which we will, you'll see this be posted. Okay. So what if you wanted to, say another truth, and you wanted to say that based on what a was? So if you wanted to add on to this, you can just type in else if, again, put in your open brackets and close brackets for the condition, the code block open and close. In here, in the condition here, let's say we want to check for if a is equal to 2. And if a is equal to 2, we're going to say something different this time. We're going to say February comes after January. Okay, so if we run this right now, since a is still 1, it'll say this. If we set this to 2, it'll say that. And you can add on to this as much as you want. You can add another clause if you just say else if, put in another open bracket, and let's say a is equal to, or let's put a more complicated example. Let's say if a is equal to, let's say if a is equal to, let's just say if a is equal to 3. Keep it simple for now. So if a is equal to 3, so this is just adding on to the code we already have of this if statement. So I'm just going to say, March comes after February. Okay, and if you run this, since a is still 2, it'll run February comes after January. If we set a to be 3, we'll get March comes after February. But what happens if we set a to 4? What you'll see is nothing, because what happens here is it'll check this first condition, it'll be false, so it'll skip this code block, go on to the next else if check, and it would again check this condition, which would be false once more. Once this condition is checked and it's like deemed to be false, it would actually skip this and just continue on. And since there's nothing here, nothing gets printed. So to handle that, we can add another line, which is always at the end of the if statement chain, and that's called else. Now the else doesn't have a open bracket, close bracket for conditions. It just checks to see if every other condition was false. If so, it will run this, whatever's in here. So in this else condition code block, I'm just going to say, I don't know what to say. Okay, so when a is 4, none of these conditions are met. So when we run this command, you'll see that. So again, if a is 1, we get that. So that's the basic if statement, structure. Now you can add more conditions to check for by either putting in an else if, or you can actually add conditions onto your existing checks by adding the and symbol for checking to see if two conditions are true. So if a and b is true, so let's say if a is equal to 3, and we added a new variable here called tell truth, and we're going to set that to be, in the beginning, let's set that to true. So if A is 3 in this condition and tell truth is true, so I'm going to check to see if that's true, then I will say this. So if I set A to 3, what you'll see is it'll say March comes after February, which is correct. But if we set this to false now, so tell truth is equal to true will not be true anymore, so it's going to be false. Since I have this AND command, it will try to validate both conditions, and if either one fails, it will not run it. So yeah, so you'll see that even though A was 3, since this is false, it just skips the this code and it goes to the else because it didn't know what else to do. Similarly, there's the OR, which is actually yeah, so it's just the two lines here, and if you don't know where this is on your keyboard, it's the same key as the backward slash. I'm not sure if that's called a forward slash, but you just hold shift for that. And now what happens is, regardless of what A is, so if A is 1, it actually checks this, and since it's immediately validated to be true, it'll run this and skip everything else. If A is 2, it would do that same thing. But let's say if A was, oh, you know what? Let me just add this class to this. It'll be more interesting if it was up here. Yeah, so if A was 3, what would happen? So it would go through here and see that A is not equal to 1, so this is false. It would go here and say that, A is not equal to 2 either because it's 3 right now. This is false. But since we're adding this OR clause here, it'll check to see what this other condition is. And since this condition is always, if I set this to true, if this condition is true, it'll actually just run this and skip the rest. So even though this is 3, it'll run February comes after January. Yeah, so regardless, so basically whatever you put in here, any number, it doesn't matter. It'll never go to the else or anything else because this condition is always true here. So this is what you'll get. That's the basic structure of the for loop. Next up, we'll do a little example. Okay, so we'll start off with the usual void setup, and our canvas size will be 1000 pixels by 1000 pixels. Our background will be white. So if you try to understand how this dot network works, it's basically a bunch of random points that are spread across the canvas, and every time we create a point, we check with all the other points that exist and check to see if it's if they're between a certain distance, and if it is within that distance, we connect it with a line. If not, we do nothing. So to get started, we need to create a few variables. The first one is obviously the number of dots that we want to create on our screen. So we'll set that to 1000 for now. Next up, we need to create let's use a float for this. This is the maximum distance. So if it's beyond this distance, we don't connect it with a line, the 2 dots, and this will be 50 for now, 50 pixels. Now we can get started with our for loop, which will draw the dots. So our for loop will start at the value of 0. Oops. And it'll go on until it reaches, so if it's less than num dots, because that's how many dots we want. We don't want this to be less than or equal to, because then we'd actually have 1001 points on the screen instead of 1000 because we start at 0. The increment for I will be 1. And now we can start with, I'll introduce the p vector, which is another variable. It's like the integer. It's like a variable type, new point, but this is actually a special variable which holds a coordinate, so 2 values or 3, it could be an x, y, and z coordinate, into a single variable. And we can declare it by typing in $, and then we have to use the special keyword new, because this is a Java class. So to create an object which is usable from this class, which is like a special type of variable, we have to use the keyword new. Then we type in p vector and open close bracket, inside the open close bracket, we have to give it the x and y coordinates. And since our x and y are both random, we can just type in x, which is random, which starts at 0, goes until the width. And our y can actually be, we can copy this, we just need to change the width parameter to height. And we'll end off with a bracket. And immediately after, we can start doing an ellipse. And remember, an ellipse takes in the x, y coordinate for the center, as well as the height and width of the ellipse. To get our x, y coordinates from this new point, which is what we just created, we can do new point dot x. Similarly, new point dot y. For x and y, I'm just going to say 5 pixels by 5 pixels. Now, if we run this, we'll just see a bunch of random circles all over the place. Now, we didn't actually store any of these circles, like positions, in a variable. To do that, we actually need to, I'll introduce a different type of variable, which is, well, it's not really a different type of variable. It's called an array, which basically stores a list, or like a bunch of variables of the same type. So we're going to be creating a list of, an array of p vectors. So that's done by typing in the variable type first. Then we put in a open close square bracket to denote that this is going to be an array. We'll type in the variable name. And then for declaration, we actually have to use the new keyword again, because an array is, again, think of it like a higher class variable than an integer or a float or a string. Actually, strings, sometimes you need to use the new keyword for the Java string object. Anyways, new p vector, and we don't use the normal brackets, we use square brackets again, and inside these square brackets we put in the size of the array. So how many rows does this array have? So you can think of an array as a single column in this case. It has like a number of rows which you can put in values, and the first row is always the 0th index. So the number of dots is actually what we're going to be using for the size of our array. And to access an element of our array, so if you remember, if the first element is at index 0, we access it by typing that. So this would give us whatever is in the first row of the column. Similarly, you can type in, any number here, and this, for example, would give us the third item in the list. To get the last item, we do 999 and not 1000, because since there's only 1000 elements, 999 is actually the 1000th element. Cool. So we have our array that can store the dots. Now, to actually store the dots, we have to do dots, and then we choose the index to store it at. Remember, we start at I. In this for loop, we start at 0 and we go up to num dots. So every time we add a new dot, we can think of it as a new index and also add it to our array at the same time. So dots I, I'm going to say that is equal to new point. So that'll remember our dot that we add in, and we'll just draw the dot here. And here, now what we need to do next is actually create another for loop. This one will use the j variable because it has to be different from the first one. We'll again start at 0, and this is basically going to loop through every dot that exists. Okay. To do that, j actually has to be less than. So if you think of it this way, in the very beginning, I is 0, right? We create a new point. Dots 0 is new point. So we have one dot. If we have one dot, we don't need to check its neighbors, right? So if you think about it this way, like this for loop would actually not run if first. By the way, we have to set this to be I, because if j is 0 and I is 0 as well, 0 is not less than 0 actually. So this would be false, and the loop will never run, which is fine because we don't want it to check to see if it's a neighbor to itself, the new point that we're talking about. So by the way, j++. Okay, so we have, okay, so let's think of the second loop iteration. So when I is 1, we actually have 2 points, right? So we start j at 0, then if zero is less than 1, which is true, this loop will run once, and it would check basically the only other element. It will check the 0th element, which is the only other dot that exists in the list. It'll be more clear when I run through this example, hopefully. So we have this for loop that checks basically every other dot, and we can get this dot, by extracting it from our list. So we'll say p vector, and we'll call it old point, and we'll say it's equal to basically dots and the index we want to look at, which is j. And what we want to check is, so we have we have this old dot, which is basically another dot that exists in this list of dots, and we also have our new dot. So to get the distance, we just do float distance is equal to, we use the function called dist. We pass in basically the first points x and y, and then the second points x and y. So if our first point is new point, so new point dot x, new point dot y, and similarly old point is our second point, so old point dot x, old point, y. Okay, cool. So now we have a distance. What do we do with this distance? Well, we have to use a conditional here. So if this distance is less than or equal to the maximum distance, what we do here is then we create a line between the 2 points that we have. So in here, remember, to create a line, we need the first points. So a line is basically between 2 points. So we need the x of the first point, y of the first point, x of the second point, y of the second point. And if you remember again, it's the same thing here. We can just copy paste this. If our first point is the new point, then we need the x, y, and then our second point is the old point, so x and y. We'll close that off, and yeah, we'll do that. And by the way, I think we're basically done. So let's just run this code and see what happens. Already, you can see it looks very similar, but we didn't add any logic for the thickness of the lines. We have all the logic for the distance. We're checking for the distance. Every time we create a new point, we're adding that point to our list so we can remember it. And this loop here checks every other point except the last point that we added, because remember, this is less than. You could change this to be less than or equal to, and the code will run fine, but it just checks itself to be as one of those points it checks against, and that's really it's unnecessary. If you'll understand if you look into lists, how they work. So yeah, that's just the logic behind that. And so what we're doing here is, we get the old point that we're checking against. This is our new point, by the way, that we just created, and this loop goes through every other point that exists in this array of dots on our screen so far, and we check to see if the distance is between, so if it's less than the maximum distance, and if it is, then we draw a line. If not, we don't. Now, before we draw the line, we can to figure out the line thickness, how thick it's going to be. We can try looking at its distance. And the logic would be basically if the distance is greater than, if it's very big, then the line has to be thin. And if the distance is very small, then the line has to be thick. So before we get started, we'll create a new variable called maximum line or maximum stroke weight. And we'll set that to be, let's say, 4 points, 4 pixels. Yeah. And what we basically do is we'll create a new variable called stroke weight. And this looks very similar to the function, so I'm just going to call it SW. And we'll set it equal to, basically, we're going to be trying to map a distance, right? So we're going to be using the map function, and it's because we take the distance, which goes from 0 to 50, because remember, this condition checks to see if distance is less than or equal to maximum distance, and since maximum distance is 50, if the distance was 60, this code right here would never run. So we don't need to worry about the distance being greater than the maximum distance. So we're going to be calling the map function, sorry. Okay, inside, we're going to be tracking the distance variable because that's what changes. And the values, so the next two parameters will be basically what are the ranges, what's the range of the distance variable. And as we know, it can go from 0 to the maximum distance. And the next two parameters will be how do we want to map our final result, which is going to be our stroke weight. And if you remember, we want it to be between 0 and 3. But the logic is kind of switched here. So basically, if distance is closer to 0, we want our output of the map function to be closer to the maximum stroke weight. So we're just going to copy that, paste it here, and the next value is basically telling the code, like, if the distance value is closer to this distance, like this value here, what do we want the result value to be of the map function? And remember, if the distance is approaching 50, so if it's really large, we want the thickness also to be, very large, very small actually, very thin. So I'm going to put 0 in there. You could put 0.1 if you wanted to, but I have a feeling it's never going to actually be equal to 50. It might, but yeah, it's just something to take care of. Yeah, so we have the stroke weight here. So to change that, we just call the stroke weight function, pass in stroke weight, and now when we run this, you'll see that we actually have very thin lines when the dots are far apart, very thick lines when the dots are close together. Yeah, so hopefully that is clear. We've introduced, we've learned about arrays and also the p-vector, which is a special type of variable which stores basically multiple values together into one variable. And yeah, if you have any questions, just put it in the comments down below. And thanks for watching.